Welcome to your tutorial on simultaneous linear equations. Let's check your audios are working first. So, hello Jasper.
Hi.
And hello Stacey.
Hi.
And hello Harry.
Hi, Alvin.
So, let's look at our objectives for today's lesson. We're going to draw some graphs of equations to be able to solve them simultaneously. It's one method of solving simultaneous equations. We're going to have a go at that. And secondly, we're going to solve some simultaneous equations algebraically by elimination. So let's have a look at our key words to make sure we all understand the words that surround this topic. The first one there is simultaneous. Stacey, any idea what simultaneous means?
Is it something like together?
Yeah, well done. That's really good. It's together or at the same time. And Harry, what does linear mean?
I know it's something to do with straight lines.
Yeah, well done. Yeah, exactly. It is to do with straight lines. It comes from the Latin, actually, from a Latin word, and that's the linear bit, and it actually just means line. But in our situation here, we tend to mean a straight line, so well done. And Jasper, what about intersect? What does intersect mean?
That would be where the two lines cross.
Yeah, well done, Jasper. And just to finish off, I'll just finish the last two off. Eliminate is to get rid of something, and substitute means to change something by replacing with something equivalent. I did always used to think it was a good analogy to use football with this, that you take Beckham off and bring Messi on. It's not quite like that in algebra. You've got to do it with something that's equivalent, and those two obviously aren't equivalent. And there's me. I'll come up throughout the PowerPoint presentation. You can ask me any questions anytime you like. Okay, so we're going to have a look at what simultaneous equations are. They're usually a pair of equations with two letters. Often they're x and y, but they're not always x and y. There can be others. The letters, when you get the numerical answer to them, they must fit both of the equations at the same time, together, simultaneously. And one method of doing this is to draw graphs. And that's the first thing we're going to have a go at. The equations will be straight lines, like Harry said earlier, and we've got to draw both of those lines. And the solution will be where the two graphs intersect, where they cross. So here we are. Here's our first example. So we're going to solve these two simultaneous equations, x plus y equals 5 and y equals x plus 1. So the way I would do this, and the way I suggest you do it, is to do a table of straightforward values of x. So starting from 0 is always a good place to start. And then you substitute those values of x into the equation x plus y equals 5 this time. And as you do that, you can fill in the y values, and that gives you a pair of points to plot on your graph, and that's how we're going to draw the graph. So, could you, Harry, tell me the y value when x is 0?
Is that 5?
It is, yeah, well done. So let's do that one first. Well done. And Stacey, can you tell me the value of y when x equals 1?
4.
Well done. That's really good. Jasper, can you just finish the rest of them off? You can see the pattern there now.
Yes. Will it be 3, 2, 1, and then 0?
Well done. That's really good. So you can see, as we thought it would, it draws a straight line graph. So this is the graph drawn now of x plus y equals 5. We're going to just do the same thing now with y equals x plus 1. So another table, simple values of x again, and we're going to do a similar thing. I'll just lead you through this one. I can see you did really well and know how to do that. So y equals 0 plus 1 will be the first point, which will be 1. And this time, the second time, it'll be 1 plus 1, so y equals 2. And 3, 4, 5, and 6. Okay, then we draw that line in. And we're looking for that point of intersection, the point where the two graphs cross. And that point is, Stacey?
It's x equals 2 and y equals 3.
That's absolutely great. Well done. All the points on that first line satisfy x plus y equals 5. All the points on the second line satisfy y equals x plus 1. And as you said, the point of intersection, 2, 3, we'll just draw it onto the graph there so you can see it visually as well. But one final thing, it's really good to check back that those two coordinates, 2, 3, actually work in the first two equations we've used. So let's go back and do that. So there we go. It would have been x plus y equals 5, but we're using 2 and 3 for x and y, and we can see that 2 plus 3 does equal 5. So that one works. Let's put 2 and 3 into the y equals x plus 1 equation, and we get 3 equals 2 plus 1. 3 equals 3. So we've proved that one works as well. So we've checked back and we know we've got the right answer. So that's the solution of these pair of simultaneous equations, x equals 2 and y equals 3. Well done, everyone. Okay, like we said in our objectives, that's a graphical method of doing it. But also, and a lot of times in your exam papers, you will be able to, or you will be asked to do this algebraically. So here are our two equations this time. 2y plus 3x equals 13 and 5y minus 3x equals 1. So Harry, which of those terms, the x terms or the y terms, would you get rid of first? Would you eliminate first?
X, I think.
And why would you get rid of the x first?
Because they're both 3x.
Yeah, well done. That's exactly the right answer. The quantities of x are both the same. They're both 3x. And as you can read on the screen there, it doesn't matter that one of them's a minus quantity and one of them's a plus quantity. They've got the same coefficient, the word is. So they've got the same number before the x term. It makes them much easier to get rid of. So we've got a plus 3x and a minus 3x. Jasper, do you think we are going to add the equations together or take them apart?
Add them.
Add them. Well done, yeah. I totally agree with you. We're trying to remember things in maths so we can use it again in the future, and there's a little rule, SSS, same signs subtract. And as you've said though, Jasper, we don't have the same signs here, so we're not going to subtract. We're going to add this time. And here you see this, the signs are different, and so we're going to add the two together. Okay, Stacey, can you add the first two terms together then for me?
Is it 7y equals 14?
Well done, that's great. Okay, and where would you go next with that then, Stacey?
I would divide by 7 and get y equals 2.
Great, that's really good. Divide by 7 and get y equals 2. Super, that's great. And what will you do with that next, Harry?
Substitute y into one of the values.
Y equals 2 into one of the equations, yeah, absolutely right,
Yeah.
well done. So let's try putting y equals 2 into equation 1. We're going to get, and just a little hint there, I always pop up and give you little hints. It doesn't matter which one you use at this stage. You could use equation 1 or you could use equation 2. So we'll use equation 1. So we've got 2, and in the bracket the value of y, 2 times 2 plus 3x equals 13. So 4 plus 3x equals 13. Next step after that, Jasper?
Um, hmm.
What are you trying to get rid of on the right, left-hand side of the equation?
Um, uh, no, the 4. Sorry.
Yeah, you're trying to get rid of the 4, so what have you got to do then?
Take 4 off the left and add 4 onto the right. No, take 4 off both sides.
Take 4 off both sides. Well done, Jasper. So 3x equals 9. And the next step, Jasper?
Um, oh, sorry. Divide everything by 3.
Well done. That's
So
great.
divide x by 3 and divide 9 by 3.
That's great. Well done. And so we get the answer x equals 3 and y equals 2. Now, if you remember when we did this graphically, the next thing we did was to actually check that those values work. And this is what we're going to do this time as well. But now we've already used equation 1. So let's use equation 2 to make sure that it works when we put these values into equation 2. And there you can see 5 times 2 is 10, take away 3 times 3 is 9, 10 take away 9 is 1, so it's proved that it works in equation 2 as well, so we now have checked our answers and we know it's the right answer.